What is going on, everyone? My name is Kodamore and welcome back to the New Beginner Java Game Programming Tutorial Series, episode 25. In this episode, we are going to be learning about animations. Now, animations are a great way to get your game to look more like a game, and they add a ton of artistic value to your game if you have good art skills, unlike myself. Now, after animation, we should hopefully be moving on to a few topics that will actually make our game more like a game, because right now we can just move around a player, and that's not fun at all. But for right now, we are just going to learn animations that'll make our game at least look a little better. As you can see, I updated my sprite sheet here, and I added a bunch of animation frames. These two sprites right here are the down animation. These two are the up walking animation, these two are the right animation, and these two are the left animation of my player when he's walking. Now, my animations are only 2 frames each, so walking down only has this picture and this picture, part of the animation. But if you're a good artist or whatever, you can have way more animation frames. You can have the walking down animation be 10 frames long and it can be really complex, or you can be like me and just have a 2 or 3 frame animation when the player is walking down, whatever you wish. It can be however many animation frames that you like. Now, the first step to create animations is to actually load up all of those sprites and crop them out of the sprite sheet in our assets class here. Now, because our animations are multiple sprites long, what we're going to do is instead of storing each one of those as a buffered image, we are going to create a buffered image array for every animation that we want. You'll see what I mean. So I'm going to delete my player buffered image, and I'm not going to need that anymore. And instead, up here, I'm going to create a public static buffered image array, so an array of buffered images, and I'm going to call this player underscore down. And this is going to be an array of buffered images of every image that makes up my down walking animation for my player. So now what I can do is I'm going to do player underscore down is going to equal a new buffered image array, and my animation is 2 frames long, so I'm going to pop in 2 there. Of course, if you had a 5 frame animation, you would put 5 there. Next, down here, I'm going to say player underscore down at 0, so the first image of this animation is going to be equal to our sheet.crop. We have to crop something from our sprite sheet. And in my case, the first animation frame for walking down is at width times 4 in my sprite sheet, so I'm going to do width times 4, and it's at 0, and then width and height. You guys all know how to do this. And then what I'm going to do is I'm just going to copy this line down and copy it here. Now, player down animation at 1. So the second frame of my animation is at width times 5. So I'm just going to crop out another part of my sprite sheet to make up that animation. And that's it. Now we have an array of buffered images that contains this image right here and this image right here. The 2 images for walking downwards. You can go ahead and do that for your up, left, right walking animations. You can make tile animations for water or something. Do whatever you'd like and load those up into your assets class like I'm about to do right now. So I've gone ahead and I've created 4 buffered image arrays, player down, up, left, and right, that will hold all the images for my player walking animations, and I've initialized them exactly like I did the player down buffered image array. I've initialized them, and then I've set all of the elements in them equal to something cropped out from my sprite sheet, the proper image cropped out from my sprite sheet. Alright, now before we get on to actually having these animations work in our game, we have to figure out exactly what we want these animations to do and how to do it. Now, my animations are only 2 frames long, but for this example, I'm going to say that my animations are 3 frames long. So this is my walking downwards animation. Now, we already have a buffered image array. I'm just going to call it frames. And in this case, it has 3 elements, or however many elements your animations have. So in this case, frames at index 0 would be this image, frames at index 1 would be this image, frames at index 2 would be this image. And what we want is we want to cycle through all of these images and render them at different times to make it look like my player is walking downward. So in order to do that, we are first going to need some index. Which image should we currently render to the screen? Are we rendering image 0 here? Image 1 or image 2. So this index variable is going to basically be the index of our array, frames at 0, 1, or 2, or whatever animation frame you have. Which frame should I currently render to the screen? Alright, so we have that, except this index variable needs to be able to change to give the illusion like our player is actually walking. So we're going to need some speed. For instance, every second we want to switch frames. So index is equal to 0. For example, let's say we want to wait every second. So 1 second passes. Alright, we're going to increment index to be 1. Now this image will be displayed. 1 more second goes by. Alright, we're going to increment index again, and we're going to display frames at 2. One more second, and we're going to loop back to the beginning of the animation, and this is going to repeat over and over and over again. Alright, so we need a speed. How often do we switch frames? And finally, we are going to need some type of timing system to keep track of time. So this timing system will say every single second, alright, increment the index. Or whenever this time exceeds our speed, increment the index. Or change images, essentially. So hopefully that cleared it up a little bit. We're basically going to rotate through all of the frames in our buffered image array and display them to the screen at different times. Now let's get to actually coding this. We're going to go ahead and create a new class, so right click on your graphics package, create a new class, and I'm just going to name it animation. And like we said, our animation is going to have a private integer speed and index, as well as a private buffered image array of frames, the array of frames that we want to rotate through. And we're going to work on the timing system in a little bit. So we're going to create a public animation constructor, taking in a speed of our animation, as well as a buffered image array, all of the frames of the animation. So this dot speed equals speed, just going to set these variables. This dot frames equals frames. Next, we're going to create one more method, and this is going to return a buffered image. So public buffered image is just going to return a single buffered image. I'm going to call it get current frame. So this is going to get the current frame of our animation. And all it's going to do is return frames, so the frames array, indexed by our index variable, just like we showed in the example. And that reminds me, up here we want to set index equal to 0 to begin with to show the first image. Alright, perfect. That works, except now we have to implement our timing system. Every second, we have to change this index variable to change which image this getCurrentFrame method will return. So we're going to create a public void tick method that will be called every time we tick our game. Now, in order to keep track of time, we are going to need another variable. It's going to be a long, and I'm going to call this last time. And in here, we're going to say last time is going to be equal to system.currentTimeMillis. This is going to get the milliseconds that have passed since the start of our program, essentially. And we're also going to need one more long variable, and it's going to be called timer. And timer, we are just going to initialize to 0 to start. Alright, now let's get on to the code. Every time we tick, we have to add to our timer, so timer plus equals system.currentTimeMillis, so the current milliseconds, or how many milliseconds have passed since the start of our program, minus the last time. Basically, this is just going to get us the time in milliseconds that have passed since this tick method and the previous tick method call. And we're just going to add that to our timer variable. And then next, we're going to set our last time equal to system.currentTimeMillis to reset it to this tick method's time that it was called. You guys should hopefully understand this because this is very similar to our game loop, so I'm not going to spend much time explaining this part. Basically, we are adding to our timer the amount of milliseconds that have passed since the last tick method call and this tick method call. Now we're going to check if our timer variable is greater than the speed that we have set, then we have to increment our index variable and set timer equal to 0 again to reset everything. Except this is going to cause a problem. My animations are only 2 frames long. So once index increments to number 2, well, it's going to throw an index out of bounds exception, which is bad. So we have to check if our index is greater than or equal to, because arrays are indexed starting with the number 0, frames.length, the length of our frames, then we're just going to set index equal to 0 again and restart the animation. And this should be length. So that will prevent any errors from happening. So whenever we call tick, it's going to change the timer. Once our timer exceeds our speed that we passed in, we reset the timer, increment the index to change which animation frame we are currently showing, and then make sure it doesn't go out of bounds of our frames array. And getCurrentFrame is just going to return our buffered image array at whatever index variable it currently is. That is it. This is the animation class done, and we can use it for so many things. Now let's head on into our player class and actually implement an animation. So up here, we're going to create all of our animations. So I'm going to create a private animation. I'm going to call it anim down for our down walking animation. Go ahead and import your animation class. And down here, after we do our bounding box and whatnot, we're going to initialize our animation. So anim down, our down animation is going to be a new animation. And I'm going to say a speed of 500 milliseconds. So this means every 500 milliseconds, which is half a second because there's 1000 milliseconds in every second. So 500 milliseconds is equal to half a second. You can play around with the speed number and see what speed your animation works best. And then we need the actual animation frames. In our case, it's just going to be assets.playerDown, our array of down walking animations for the player. That's all we have to do to create an animation. Next, in our tick method, before we do anything, we are going to do animDown.tick. We're going to tick our animation, and I'm just going to add a few comments there. So we're going to tick our animation to update the index variable. Next, down in our render method, we have to do that animation. So we're going to do animDown.getCurrentFrame to get the current animation frame, or which image we should currently be rendering from that animation. Now, if you go ahead and run your game, you're going to see that I have a down animation. As you can see, my player looks like he is walking downwards. Kind of. My art isn't good at all. Except now when we walk up and left and right, it doesn't change at all. So we have to, of course, change that. And this is pretty simple. Below our render method here, I'm going to create a private method. It's going to be a private buffered image. It's going to return a buffered image. I'm just going to call it get current animation frame, like so. And for right now, I'm just going to return animDown.getCurrentAnimationFrame. We're going to change that in just a second. And then in our g.drawImage, instead of hard coding an animation, we are just going to say get current animation frame, like so. And that didn't change a thing. So let's go ahead and let's add a few more animations. I'm going to do this off camera because it's pretty self-explanatory. So I've gone ahead and created 3 other animations, and I'm up, left, and right. I've initialized them here, and I'm also ticking them every time we call the tick method there. Now the real change is going to be in our getCurrentAnimationFrame method here. So I'm going to delete this, I don't know why I typed it. And we are going to display a certain animation depending upon which way we are moving. So I want left and right to override going up and down. So I'm going to check the x-axis first. So if our x move is less than 0, meaning we are moving to the left, because a negative number means we're moving left, we are just going to return our animation left.getCurrentFrame. Else, if x move is greater than 0, so we are moving to the right, we're going to return animation right.getCurrentFrame. Else, if, now we're going to check our y move. If y move is less than 0, which means we are moving up, we're going to return animUp.getCurrentFrame. And else, if all else fails, we are just going to return animDown.getCurrentFrame. Now you could also add another animation for standing still and just return that as the default and add an extra else if statement for moving downwards. Alright, so this is going to return the proper animation and the proper animation frame depending upon which way we are moving. So if we run our game, as you can see, walking downwards works, upwards works, and as you can see, standing still works. It just results to the downward animation for me. Walking right and walking left works perfectly. My terrible animations, but hey, it's working. We got animations working, and it should work with any number of animation frames, whether you have 3 frames or 20 frames. That's all for this tutorial, everyone. It was kind of a long one, and I apologize for that, but we got animations working. Now let's finally move on to making this game an actual playable game. Thanks for watching, everyone, and I'll see you guys in the next tutorial.